Hi everybody, welcome back. We're going to hopefully finish off 1.5 today, the infinite series. There are two types of infinite series, and the first one is called a convergent series, and this is going to be a series with an infinite number of terms in which the sequence of partial sums approaches a fixed value. Okay, so for example, one plus one half plus 1/4 plus 1/8 plus dot dot dot. So 1/2, 1/4. You can clearly see that it's being cut in half each time. All right. So for this, we say if -1 is less than r is less than 1, so basically between -1 and 1, the series is convergent. So it'll approach a fixed value. You have to calculate that, and you'll do it a few times like we did back in the infinite series example on page 24. We could see that it was clearly approaching a fixed value of 72. The R value was 1/3. So it approached 72. It's getting closer and closer to the point where if the calculator is giving you 72, we put S as 1,000, the same thing will occur. All right. And the second we have is called a divergent. Divergent. A similar, I'm going to steal this for a minute. It's a series with an infinite number of terms in which the sequence of partial sums does not approach a fixed value. For example, 2 plus 4 plus 8 plus 16 plus dot dot dot. So this has an R value of 2, obviously. So this will occur if R is less than -1 if R is less than -1 or R is greater than 1. The series is divergent, which we saw in the second example, 3, 12, 48, 120. We noticed that it kept going, and it goes on forever, essentially. And that's where the infinity comes into play. That's where we're going next. So examples, it says, example A is 16, -12, 9, -27. 4, it's plus 18 over 16. So in this example, what we'll do is we'll write down what we have. First thing we know is we have T1. So T1 is equal to 16. And we have R equal to, and it's 12, negative 12 divided by 16, which can be simplified to negative 3/4, right? So it's 9 divided by negative 12 or negative 12 divided by 16. Either way, your common ratio is going to be negative 3/4. So we say, and I'm going to steal that since our R value is between -1 and +1. So I'm going to steal this for a minute. We say, since -1 is less than R, the series is convergent. Now we can calculate that. So we calculate the sum, and this is our new formula. It's our final formula for this section, and it's given by the sum as we approach infinity is equal to the first term, T1, divided by 1 minus R. This is the formula that we're going to use to determine the sum to infinity. And that's going to equal, and in this case, I'll copy this, and our first term was 16. Our R value was minus, I'm going to insert a fraction of negative 3/4. So a negative multiplied by a negative, as you know. So the negative, negative multiplied by negative positive, or subtracting a negative is the same as adding the opposite, so adding a positive, whatever way you want to look at it. So that denominator is going to be 1. Add that, we end up with the denominator of 7/4, right? 1 plus 3/4. And that's going to equal 16. And when we divide by a fraction, we multiply by the reciprocal, so it's 4/7, which is equal to 64/7. So what does that mean? That means that we can keep putting numbers in. We can keep putting in as many numbers as we want. You could use the old formula there for the sum, and you're never going to get a number higher than 64/7. Keep plugging it in, it's not going to work. All right, and this is converging to a fixed value of 64/7. So you'll learn a lot more about this once you get into the calculus course this time next year. Now let's do another. All right, so the first term we have here, T1 is equal to my fraction 4/5, first term, and our R value this time, our R value is 1/3. 1/3. So 4/15 divided by 4/3 will give you the 1/3, or you can clearly see that the numerator is being multiplied by 1 and the denominator is multiplying by 3 both times. So either way, it depends on how you want to look at it. Again, since the R value is between -1 and +1, the series is convergent, and we just do the sum. Put our fraction in here. So we're going to plug in. So our T1 value is 4/5. That's also a fraction. I need another fraction. There we go. 4/5. The R value is 1/3. So that's going to equal going to equal 4/5 divided by 2. Oh, gotta put another fraction in here. Divided by 2/3, which when we divide two fractions, that's the same as multiplying by reciprocals, right? So it's the same as multiplying by the reciprocal. I'll show that in brackets. I like to have brackets there, right? And that's a little, we don't like dividing by fractions, so we multiply by the reciprocal, which gives us 12/10. Again, and we can simplify. That should be a practice that we're getting used to now as we simplify our fractions. 6/5. So that means that no matter, we can pick as many terms we want. Higher term we go. This will never go past 6/5. So it's converging to 6/5 to a fixed value. The next one is a little different. Try to get this in time. So the first term steals 1/8. And obviously it's the R value is equal to 2 because we're increasing by a multiple, a common ratio of 2. We multiply 1/8 by 2, we get 2/8, which is 1/4. Or we take 1/2 divided by 1/4. However way you want to get to it. Either way, your R value is going to be equal to 2. So this time we'll do the same thing. Actually, sorry, we don't, because our R value is greater. So we say, we go up here and we say, since R is greater than 1, the series is divergent. It'll just keep going and going and going, which means it has no sum. It's heading to infinity, right? It'll just keep getting larger and larger and larger and larger. We have one more example. I don't want to rush it through. I only have a few minutes left with my video. So in the next video, we're going to finish up the chapter, actually. And we have a cool little question we do. I remember doing this one in high school as well. So one more video for this chapter. I hope you're enjoying the videos. I think they really will help with different learners we have in the class for sure. So we'll see you again soon for the final video. Thank you.